Welcome back, Warhawks. This is Mr. Tipton. Today we are doing Chapter 6.3, Proportionality. Um, in Chapter 6, we've been talking about triangles so far. Today that's going to hold pretty true. We're going to be dealing mostly with triangles. We're going to be talking about angle bisectors, triangle proportionality, proportional segments when we have parallel lines, and also triangle midsegments. I don't think that you guys should have too much trouble with this. Just pay attention, and we'll get through it hopefully rather quickly. The first part we're going to talk about is angle bisectors in a triangle. If an angle of a triangle is bisected, the opposite side is divided into proportional parts. So if we look at this, we see that angle A has been bisected by AD. The proportional parts, though, is actually this side is going to be proportional to the sides that it's adjacent to, and your book talks a little bit about that. Just thought that was maybe a little bit too much to write, but I think you'll be able to see this relatively easily. So we have a bisector here of angle A. AD bisects angle A. Therefore, 5 is to X as 8 is to 4. So we write out that proportion. 5 is to X as 8. Oops, having a little trouble writing. 8 is to 4. To solve a proportion, all we have to do is cross multiply. So I multiply 8 times x, which gives me 8x. And then I multiply 5 times 4, which gives me 20. Now, some of you may already see the answer. 8 and 4. 4 is half of 8, so x is going to be half of 5. But when we divide by 8, we do get that answer that x is 2.5. And there we can see the proportional sides, that 4 and 8 are proportional to 5 and x when we have an angle bisector. Let's look at another one here. Here we have an angle bisector. Again, A is bisected. It's cut into 2 equal parts. So 5 is to 15. Or 15 is to 5, I guess I will say. As 18 is to y. Now, you may already see the answer because you know that 5 is 1/3 of 15, and what number is 1/3 of 18? But when we go ahead and cross multiply, we see that we get 15y. We multiply 15 times y, and we get 5 times 18. You may not know that, but it's actually 90. And then a simple calculator, use of the calculator. Holy smokes, I'm having trouble writing here. All right, hopefully I get this writing thing figured out. I changed the paper I was writing on. I was having trouble with that. We'll make that a quiz question. What was I having trouble with? But we divide 15 both sides. 90 divided by 15. Y actually ends up equaling 6. And there you can see that 6 is 1/3 of 18. 5 is 1/3 of 15. Here's another proportionality part we get to. If a line through the triangle is parallel to the base of a triangle, then it splits the sides proportionally. Here we can also see that we have 2 triangles. Hopefully you can see this larger or this smaller triangle and that larger triangle. These 2 parallel lines would make these angles corresponding angles and these angles corresponding angles, which would actually make these 2 triangles proportional based on angle-angle similarity. But when you see these parallel lines, we're going to have proportional sides, or 6 is to 2 as 9 is to x. You may already know the answer, but we set up our proportion. 6 is to 2 as 9 is to x. Cross multiply. 6 times x is 6x. 9 times 2 is 18. And 18 divided by 6, x ends up equaling, 3. Make that a little better. So again, those parallel lines split the sides proportionally. We look at another example here where the converse is also true. If a triangle's sides are split proportionally, we can see here that they are. 3 is to 1 as 6 is to 2. And if you cross multiplied or divided, 3 divided by 1 is 3, 6 divided by 2 is 3, or you just cross multiply 2 times 3 is 6. 1 times 6 is 6. So those are proportional. Then that means that these two lines are going to be parallel to each other. So since those are proportional, we could say that AB is parallel to CD. So that is the converse of the triangle proportionality. This is also true for 3 or more parallel lines. Here we see that we have 3 parallel lines. When you see a situation like this, these sides, or these segments, are going to be proportional to these segments, or 3 is to 6 as 5 is to x. You may already know what x is going to be because you know the relationship between 3 and 6. We set up a proportion. 3 is to 6 as 5 is to x. Cross multiply. 3 times x. 6 times 5 equals 30. Divide by 3, and x equals 10. And we can see there that 3 is half of 6, 5 is half of x, or 10. So that also is true when you have situations like this. You can just set up a proportion and you can solve. Not too difficult. The last thing we get to is a little bit different. Triangle midsegments. If the line bisects two sides of a triangle. So this is actually the midpoint of that side of the triangle. And this right here is actually the midpoint of this side. Now it's shown with bisectors, meaning that this is congruent to this, meaning that's in the middle. And this segment here is congruent to this segment, making that point exactly in the middle. When this happens, what we see is that the mid segment, which is what this is called right here, it is the mid segment, is actually equal to 1/2 of the base. Okay, it's also going to be parallel to that base, but it's going to be equal to 1/2. So you may already know what x is. X is going to equal 24. Now, if they gave you the base, then you would just divide by 2 to get the mid segment. Now, just to show that this is true, I'm going to go ahead and move this mid segment down here, put it on this base, and then over here I've actually made I cloned this mid segment over here. It's the exact same length, and I drag it here, and we can see that it fits right there onto that base. So 12 was half of 24, even though sometimes it may not exactly look like it's going to be half. I mean, to me, it looks like it's maybe a little bit longer than half, but showing you with just moving it down there, it actually did end up being exactly half of that base. All right, I hope you enjoyed, and we'll see you in class.